This is the fourth and final part of our lesson on calculating the abundance of isotopes using algebra. We'll pick up where we left off in part 3 when we looked at what to do when we have more than 2 isotopes, but this time we'll have slightly different data to work with. Here's the learning outcome for this lesson. We'll learn how to adapt the method you used in parts 1 and 2 of the lesson to calculate the abundances of more than 2 isotopes of an element. But this time, we'll know the relative abundances of 2 or more of those isotopes. Even though we're given slightly different data then, it will be very similar to what we did before. We'll be using the same rule that the total abundance is 1, and we'll be using the same equation, the equation being the relative atomic mass is equal to the sum of the mass times the abundance. To see how this is different but also kind of the same, let's get straight in with an example. Here's our first example then. We have another hypothetical element, L, this time, which has 3 isotopes, and they are L10, L11 and L12. We're told that the relative atomic mass is 11.8. Now the next piece of the information we're given, this is the bit that's key. We're told that the abundance of L11 is twice that as L10. This is different than what we've seen before then. We don't know the actual abundances of any of these isotopes, but what we do know that whatever the abundances are, L11 will be twice that of L10. Now the question is asking us to calculate the percentage abundance of L12. The way that we're going to go about this is exactly the same way as we've gone about every other question. We'll start by working out how to represent the abundances. So here's our 3 isotopes. To get started, I'm going to say that L10 is X. Bearing in mind L11 is twice as abundant as L10, it makes sense to say that L11 is 2X. Now for L12, we have to work out a way of representing this. And if we think about how we did this on the last video, where we had 3 isotopes then, what we did is we used the idea that the total abundance was 1, and then to work out the abundance of the last of our isotopes, whether that was the third or whether it's the fourth, we did 1 minus the abundances of the others. Now, in the examples we saw before, we actually knew the abundance of 1 or 2 of the isotopes. So we ended up doing 1 minus that abundance minus X. Well, in this case, we don't know the actual abundances, but we do have them represented as X. That means we can do it in exactly the same way. So we can do the abundance of L12 would be 1 minus 3X. So now we have something to represent the abundances. We need to put our expression together, we need to find X, and we need to come back and make sure we can work out the percentage abundance of L12. This is where I'm going to leave it to you. You've done so many of these now, you should have the idea about how to approach it. So pause the video, restart it when you're ready to check your answer. Okay, let's see how you've done. This is the expression I got. You can see I've ended up with 11.8 equals 10x plus 11 times 2x plus 12 times 1 minus 3x. I've just put the masses and the abundances in there as usual. Then I solved for x. Same steps as before. Expand the brackets, combine the x's, simplify the equation by subtracting 12 from both sides. That leaves me with minus 0.2 equals minus 4x. So rearranging that, I can do minus 0.2 divided by minus 4, and that leaves me with x equals 0.05. If you're struggling with any of this, this is the point where it's not really about the chemistry anymore, it's the maths that will be holding you back. So if you've got any problems here, definitely go think about revising your GCSE algebra. It's worth the time because these questions involve algebra, but they're not the only part of the A-level chemistry specification that does. You've got very similar things like this with equilibrium, etc. too. Okay, answering the question, we were asked for the percentage abundance of L12. To work that out, we'll need to work out what the abundances are for L10 and L11 first. Bearing in mind L10 is X and L11 is 2X, the abundances for L10 will be 0.05 and for L11 it will be 0.1. L12 is 1 minus 3X, so that's 1 minus 0.15 equals 0.85. Now we have the decimal abundance, all we need to do to get the percentage abundance is times by 100. And if we take the decimal abundance of L12, times it by 100, it gives us 85%. Now that's that one done. I've got one more question for you, and it's very similar. So here it is. You've been asked in this case to calculate the percentage abundances of the isotopes of strontium. You've got the information to work with there. This one's for you to do completely by yourself. Pause the video, have a go, restart when you're ready. Right, let's check your answer then. Now, the key piece of information we have here is that strontium-86 and strontium-87 are present in a 1-to-1 ratio. That means whatever the abundance of strontium-86 is, strontium-87 will be the same. Based on that, it makes sense to make strontium-86 and strontium-87 X. And then strontium-88 will be 1 minus 2X. That gives us the expression 87.7 equals 86X plus 87X plus 88 times 1 minus 2X. Now we need to use that to calculate the abundances of the percentage isotopes of strontium, so we need to solve for X first. Just going through this really quickly because you've seen this so many times now, you must be sick of hearing it. By expanding the brackets, combining the X's, simplifying the equation, we get X equals 0.1. Again, you see, we said before that 0.1 is a really common abundance for isotopes, so don't be confused by the fact that that keeps popping up. Now, we have X, let's go and answer the question. So strontium-86 and 87, they're both X, so they will be both 0.1. Strontium-88 will be 1 minus 2X, which gives us 0.8. Now to finish off with, we need to multiply our decimal abundances by 100 because we were asked for the percentages. That gives us 10%, 10% and 80%. Now we've finished with our final question for the lesson, so before we finish up completely, let's just recap on that rule we've been using. We've used the idea that the abundance of the final isotope that we get to once we've worked out the abundance of all of the others will be 1 minus the abundance of the others. We saw this at the beginning in video 1 where we had 2 isotopes and the second isotope was 1 minus X. We saw it in the second video with the practice examples that were the same. We saw it in video 3 where we had 1 minus the abundance we knew about, minus X. And we've seen it here where we have 1 minus the X's, which represent the abundance of the isotopes. Now, that's it, we're done. You're pretty much an expert at these calculations now, so you should be prepared to tackle any question that gets thrown at you. You may see something in the exam that looks a little bit different to what we've done here, but remember that's always the way with A-level chemistry. They're testing not just your ability to learn the rules, but your ability to learn the rules and apply them to new, novel situations. If you apply the rules and ideas we've seen here though, you should be able to tackle absolutely everything, so don't worry. Well done for making it through to the end then, and best of luck with the questions you do.